This is Physics 30, Chapter 4, Lesson 4 on the law of conservation and energy. When we're talking about the law of conservation and energy, the main premise is that energy is neither created nor destroyed, it can only change form. When we're talking about energy, we can use the equation ET equals EK plus EP, which means that total energy will be equal to kinetic energy plus potential energy. In the picture below, we can see that when the skier starts their scenario, they're not currently moving, so there's no kinetic energy, that's 0 joules. And their potential energy at 100 meters is 50,000 joules. As they descend, they'll be losing potential energy, but because of their increased velocity, they'll be gaining kinetic energy. So some of the potential energy is transferring to kinetic energy, and at this moment we see these numbers. Notice that they still add up to 50,000. At this low point, the skier now only has 15,000 joules of potential energy and 35,000 joules of kinetic energy, still adding up to 50,000. The height here after they fly off this ramp, because they have a greater height, they have a greater potential energy, but they've used up some kinetic energy to get there. And then when they finally land, there's no potential energy. Everything has been converted into kinetic energy. But the main thing to notice is that at every point in this scenario, the total energy is always 50,000 joules. There is no energy lost. Total energy can also be called mechanical energy. So in this little animation, we see the roller coaster come down. Notice that the kinetic energy and the potential energy exchange with each other here depending on the height of the roller coaster. But the total mechanical energy shown in green here always remains consistent. It's always the same. Power, we've mentioned a little bit, is the rate at which work is done. So we have this equation, P equals W over T. Power is work divided by time. And from the previous lesson, we know that work is equal to mass times acceleration times displacement. So we can also say that power is equal to mass times acceleration times displacement divided by time. We also have the equation power equals FV, meaning that power can also be calculated by force multiplied by velocity. Power is measured in watts, which is joules per second. Work is measured in joules, and time is measured in seconds. We're going to try some practice questions on page 191, numbers 2 to 8.